So it seems to me that there are two things. The first is what I've heard you talk about earlier is the triple juncture.
Triple junction,
right. And that it was probably above sea level and now pretty far below, like about more than 3 kilometers below sea level.
Right. Well, and this particular site that we just left gives us sort of an interesting clue in that if you look at Tamu Massif, it's down at the southern end and it's big, and you expect that to have been at sea level. You look at Ori Massif up in the middle, and it's big, and it looks like it had to be at sea level at some time. But this point in between now looks like it might have been at sea level, so maybe this was not just a little string of islands, but maybe a large landmass even. And one of the things that we're going to be testing at the next site is, one idea is that Tamu and Ori Massifs once sort of butted up against one another, were part of the same thing, and then a spreading ridge got in between them and started splitting them apart, and then later on that ridge jumped to another location and it froze. And so there's this little basin in between where 1348 is, and now we're going up to 1349 up on the top of Ori, and maybe we'll see if it's the same age as Tamu Massif, then that'll say that they formed together and split apart.
So right now at the site that we're at right now, are we going to drill?
Right. Well, now we're at 1349, right?
Yeah.
Because we moved away from 1348.
Yeah. So are we going to drill straight through the top of of the summit, as opposed to along the side of it?
This site has an intriguing ridge that's buried beneath the sediments at the very top. And this ridge, unlike a lot of the other cones that are bumpy, this one's has a flat top, so it looks like it was probably eroded at sea level. That's one of the reasons for drilling on top of it to test that out, because if it was a ridge and then it was eroded down to sea level, we're hopefully going to be able to drill sort of deep within it, because the ocean exposed a lot of it and then it was covered up with sediment. You know, and hopefully there's some remnant information that's up there, that maybe some beach stones or fossils or something that might tell us that it was at sea level and when it was at sea level.
And so what about the last site, which is going to be the southernmost site that
That's right. Well, then we're going to turn around and head back to the south. It was all happened because of Typhoon Choi-Wan sort of mixed our sites all up. We had to skip over these two at the very beginning. And so then we'll go back to the south of Tamu Massif and drill down there. And one of the things we're testing there is that Tamu Massif, is it all the same, pretty much the same age as we expect, or is there an age progression? And then we're also going to look at those big sheet flows that we saw at 1347. We're going to be now go 100 kilometers or a couple hundred kilometers to the south and drill and see, do we see those same things? In other words, we think that maybe that supervolcano covered over its whole flank with these sheet flows, and the way to test it is to drill it at several locations and try to see that.
So it's an intriguing puzzle, and I guess that's what geologists love doing.
That's what we do. And you have to remember that this thing is in the middle of the ocean. We've studied it mainly with just tracks of geophysical lines. In other words, sonar and seismic lines that show the shape of the ocean bottom and maybe a few layers underneath that. And they're very widely spaced. If you for a demonstration a few weeks ago before I left, I actually took a map of the state of Connecticut and put it onto Shatsky Rise with the ship tracks, and you can see there are lots of Connecticuts where there's no ship tracks, and so it's just a huge area that we hardly know anything about, and so practically every time we drill into it we're finding some new information. Sometimes it's what we expect and sometimes it's not what we expect.
And I've thought about this a lot, and I've made a comparison to oceanography, and you know, where we do a CTD cast or put a net out, and it's so much easier doing it in the water than having to go through the water and then into the earth itself, and you can get many vertical points and then interpolating between those, and it seems so much more difficult to do it in the ground.
Well, it'd be a whole lot easier if there were no ocean in the way, and we could walk across it, or even if it was on another planet and we could send a spacecraft up there. But the ocean is a great place to hide. You know, as you well know, there are lots of species at the bottom of the ocean swimming around that we don't even know yet.
Right.
Because they found a really good spot to hide. You can't see through the ocean.
It's the nature of exploration.
That's right.
Well, thank you very much.
No problem.
All right.